So here we go. The slope-intercept form is y equals mx plus b. You're familiar with that. M is usually the slope. B is the y-intercept. ax plus by equals c. There's no fractions in standard form. So if you get a fraction, you kind of have to multiply through to get rid of it. So we can talk about that. X-intercept, the x-coordinate where the graph intersects the x-axis. All right, here's the warm-up answers for those of you that might have done it. Evaluate each expression. You get 1, 3, and 7. Oh, for here?
Yeah.
Yes. Negative 1 and 2/3? Yeah. Negative 1 and 1/3. And then this one, you guys, you really just have to look at it. Take a look, take a look. In 2005, Carrie's Pet Shop had a profit of $55.5. In 2006, the profits were $38.7. That's a problem. What's happening to the profit? It's going down. And a graph of the data is the slope of the segment between 05 and 06, positive and negative. If it's going down, it's going to be negative, correct? That's all you had to do. Okay, here we go. Today, we are graphing linear equations.
Favorite thing in the world.
Yeah, it's not too bad. All right, first thing I want you to do is put this on the graphing calculator, y equals x. I want you to put that on the graphing calculator. Y equals x. Yep, yep. Only for comparison's sake, I want you to take a look at that. Ladies and gentlemen, I want you to get rid of your plot up here because it might screw up your window. So arrow up, push enter and arrow down, and then these should all be clear. Okay? So you arrow up, push enter, and arrow down, and these should all be cleared. Put y equals x, so you just do this. That's all, y equals x. But I want us all to have the same window. Right? So I want us to go to, I want to do zoom standard, zoom 6. And then your graph should look like that. That's y equals x. Every single point on this line, tell me about the coordinates. If it's y equals x, tell me about the coordinates every single point on this line. Y equals x, that means 1, 1, 2, 2, 3, 3. You said that, didn't you, Noah? 4, 4, right? If y equals x, yeah? Big picture. Okay. Now, what we're going to do in this whole section is you're going to come, this is the parent function right here. Y equals x is a parent function. It's the most basic function. We're going to see what happens when we multiply the x by negative 2. Can anybody tell me what's going to happen to the line? Which way? It's going to go down. So I want you to go down to y2, and I want you to do negative 2x on there. So it is going to be a little steeper, but then it's also going to go down. The 2 makes it get steeper, and then the negative makes it go down. So let's see if that's what happened. Yep, there it is. Okay, so what I want you to write here is, what do we notice about this? It has the same what? Okay, what's the y-intercept of this equation?
0.
Y-intercept equals 0, doesn't it? This one the same thing, because if you think of y equals mx plus b, the b is just 0 in this equation. So this has the same y-intercept. I'm going to graph y equals x, which means you're going to put points on 1, 1, 2, 2, 3, 3, and then you're going to connect them. This is y equals x. Because you're going to be comparing it to that graph every single time. 1, 1, 2, 2, 3, 3. That's y equals x. Graph it. And then we're going to graph y equals negative 2x. Well, if it's plus 0, where's my beginning point? Where do I start this graph? At 0. And then what do I do to get my second point? Down 2 over 1. Then I graph. This is y equals negative 2x. Okay? So they have the same y-intercept. I have to compare them. They have the same y-intercept. And it's steeper and it's falling because of the negative. However words you want to use, but that's kind of what I would say. When you compare the two, you say the same y-intercept, this one is steeper because of the 2, and it's negative, and it's falling because it's negative. Okay, on this one, again, I want you to graph y equals x. So it's 1, 1, 2, 2, 3, 3. Draw a line there. That's y equals x. And then here, let's graph this one. What's the slope of this one? It's 1 over 1, isn't it? So I start at negative 1. Go up 1 over 1. Oh, what am I seeing here? What kind of lines are they? Okay. So what words would you use to compare these two lines? Compare this one to y equals x. What words would you use? They're parallels. They have the same slope. Different what? Different y-intercept. Okay? Graphing. So we already know how to graph this one. What's the beginning point? Negative 2. And then what do? Right, rise over run. So you go up 3, over 4, and it's here, and you connect them. Okay, that one is already in y equals mx plus b form, so it's easy to graph. No, we're not comparing these, we're just graphing. Okay, this one is in what form? Standard form, so you have options. You can move it into y equals mx plus b. Personally, I think that takes longer, but we can do it real quick. This is negative 2x, by the way, in case you can't read it. So what I'm going to do is I'm going to add 2x to both sides, and I get negative 3y equals 2x plus 6. And then what would you do? Divide by negative 3, right on. Divide by negative 3. You get y equals negative 2/3 x plus negative 2. Now, perfectly acceptable method. So if I start at negative 2, go down 2 over 3, there's my line. That one is a little longer than finding x and y intercept. When it's in standard form, it's pretty easy to find the x and y intercept, and what I do is I make a little table. The y-intercept is when x is 0. The x-intercept is when y is 0. Do you remember this? Look, you don't even have to really do any math. If you think about this, if I make x 0, this is going to go away, isn't it? Negative 2 times 0? Yes? I just cover it up. It's gone. What's my y going to be when x is 0? Divide by negative 3, y is negative 2. Don't even really have to write anything down. You can just put your finger over it and divide. If y is 0, then this term goes away, doesn't it? Divide both sides by negative 2. What's x? Negative 3. Does it give us the same graph? Over 0, down 2, negative 3, 0. Yes, it does. So you can do it either way. My preference is this when it's in standard form. Okay? All right, y equals negative 3. This tells me that all the y values are negative 3 no matter what x is. You could pick any x, but all the y values are going to be negative 3. So 1, 2, 3, and you just draw a horizontal line. Right? You could pick any x, but all the y values are negative 3. Okay, how about x equals 4? What is that telling me? All the x values are 4. Every single one. It doesn't matter what you pick for y. 0, 1, 2. All the x values are going to be 4. So it's a vertical line. Yeah? Let's read this one. Story problems. We wouldn't want to not do the story problem. The value y of a copier x years after it was purchased can be modeled by this equation. Graph the equation. Okay, first of all, is your line going to go up or down? How come? Describe what the y-intercept and the slope represent in this situation. Use the graph to estimate the value of the copier after 5 years. So this is saying my y-intercept is 4,000, correct? And my slope is going down by 600 and over 1, so I'm just going to say about here, and this is 1, 2, 3, 4, 5, 6, 7, so it goes down about 600 and over 1. So I'm going to connect my line. How come I wouldn't go into the negatives? Because we're talking about what and what? Well, it could have a negative value, I guess, but we're not going to go there. What does the y-intercept represent in this situation? Let's read it again. The value y of a copier x years after its purchase can be modeled by this equation. What does the y-intercept represent? How much it cost when? When you bought it. Initial value. What does the slope represent?
Value of it.
Yeah, it's losing $600 every year in value. Okay? Losing $600 in value every year.